welcome back. For those of you who went outside to look at the Untitled connection, I think there were several contacts were heard. We didn't successfully make one. The next pass is about 1 o'clock this afternoon, but it's only about 1 degree, so that's why it didn't go on the schedule. Next pass is late evening today, but we've got 2 more good passes again during the morning tomorrow. Without further ado, Peter Guelzow, AMSAT-DL, well known to all of us. And to those who don't know him yet, you'll find out an awful lot about what you guys are doing. Some interesting news.
Yeah. Okay, Dave, thank you very much. And good morning, everyone. Yeah, this presentation is supposed to be an AMSAT-DL presentation. That's how we announce it. Honestly, this presentation is on behalf of the Qatar Amateur Radio Society on QARS. And it's about the first P4A, the first geostationary AMSAT transponder in space. You heard about it, I hope so, already last year. So we had a timeline for this project. So basically the trigger for this project came in December 2012. The QRS, Amateur Radio Society, organized the first HEM festival in the Arabic region in Doha, in Qatar. So there's a small typo. It's not Doha, Doha city. And they invited various amateur radio representatives basically from around the world. And I had the honor to represent AMSAT, especially AMSAT-DL activities. So I had a chance to talk about phase 3 satellites, what we achieved in the past, where we wanted to go, Moon and Mars even so. This festival was quite nice, and we had a lot of representatives from the government, including some of his higher excellences, and I think they got the message. So it took a few months, and then in early 2013, I got a phone call from the company SHILSAT Corporation, the Qatar satellite company, and basically the information they had from their government, they want to build an amateur radio satellite, a satellite for the amateur radio community. And we started discussion, okay, what can we do? What kind of spacecraft? So, not to disappoint some of you, but CubeSats were no thing, because everyone can do a CubeSat now. And you know, these countries, they always want to do something not done before. So we even discussed about phase 3E, because phase 3E was already, let's say, half ready, and having support from such a country basically to get it up, finished and launched would be a great thing. But it came out this is a little bit complicated also because of propulsion systems and things like that. So knowing that Qatar was going to launch their first communication satellite, the idea was, okay, how about putting an amateur payload on your next geostationary satellite? This would be the first geostationary payload, AMSAT payload, and already some other ideas which could be first. So yeah, that was really the thing where they said, okay, this is where we want to go. So we had some further discussions, technical discussions mostly. And then in March 2013, the Qatar satellite company made a RFP, a request for proposal, to the satellite manufacturers. Indeed, they have commercial transponders. The main purpose of the satellite SHILSAT-2 is about retransmitting broadcasting, TV channels, and other services. But they already mentioned in this paper the purpose of having an amateur radio payload. And basically, with this request proposal, you go to the various satellite companies, including SSTL, and ask them for quotations, for proposals, how can it be done, what can be done. Indeed, for most of the companies, they never heard about, or they probably heard about AMSAT, indeed. We have a very good reputation, but they had no clue what kind of transponder they have to build, because the thing is, we actually proposed that AMSAT-DL could build such hardware, but basically they just go to the big manufacturer and say, okay, we want this, we want that, and we want an AMSAT transponder according to the specification from AMSAT, built by them. So anyway, so you see, they made the press release. AMSAT-2 will be the first radio amateur satellite AMSAT geostationary communication capability that links Brazil to India in one single hop and in real time. It will allow the AMSAT community to validate and demonstrate their DVB standards as well. So this was part of an official press release, also reprinted in some of the aerospace magazines, and you can imagine everyone was curious what kind of AMSAT, what kind of deal is AMSAT doing there? So anyway, so during 2013, 2014, we had several meetings. We also had Graham Howard from AMSAT-UK, Achim, Michael Fletcher from AMSAT-OH, and we were going to Qatar several times, discussing first the ideas, some technical parameters, and finally, mainly Achim, me, and Michael Fletcher, we were in the, did a lot of telephone conferences, emails, and even attended some of the meetings, especially at the manufacturer. So in 2014, it was announced that the AMSAT-2 spacecraft will be built by Mitsubishi Electronic Company in Japan, Melco. So they are selected as a manufacturer, and they will also build the AMSAT payload. So it's not AMSAT, it's not AMSAT-DL. Melco will build space flight hardware for the spacecraft according to all the general rules in this business, meaning quality rules and so on. So we had the first design meeting in Japan, near Tokyo. Also Mikio-san from JAMSAT is here, and we thank him very much because he gave us a lot of support during our stay there. And now we recently, a few months ago, we had the critical design review. So basically the manufacturer of the satellite presented their design parameter specification, how they think it will work according to our requirements. And the next steps are now, they are building now an engineering unit to validate and verify all the specifications they got from us. So we had a lot of discussions because you can imagine an amateur radio linear transponder is completely different from a commercial TV transponder. In a commercial TV transponder, they do not have automatic gain control and things like that. It's a complete different world, and we really had hard time to explain how this has to work, because we have uncoordinated multiple access by many single users. We cannot control the units. We cannot give a phone call to say Achim and say, Achim, please reduce your output power by 10 dB. That doesn't work. In the commercial business, it works like that. They have uplinking stations, and for, say, Al Jazeera channel is too weak, the downlink signal is not strong enough, they give them basically a phone call and tell them, okay, give 10 dB more output power. So it's completely different world, and as a manufacturer, the engineers had a hard time to understand, but finally I think they did very well, and we had a very good, actually very nice technical discussions over there. And some of them were even amateur radio operators, or have been. So anyhow, so engineering units are built at this time, and we are waiting for some real measurements. And we also requested that if it is possible, JAMSAT will support us. They will set up a small station so that we can actually do a real end-to-end test with some ham radio equipment. So this is a planning, not yet confirmed by the manufacturer, but we are in deep discussions, and this will follow up over the next couple of months. And in parallel, so as I said, AMSAT-DL is not going to build any hardware. We just give our knowledge, our specifications, our advice, as basically as a consultant. And but in parallel, we are now preparing the ground station equipment So there will be a ground station located near Doha City. It's the SCC, Spacecraft Control Center. So this is the first spacecraft for Qatar which they own completely, but which they also will completely control and operate from Qatar. And they are building a completely new ground station, also for the SLSat-1 project. And part of this ground station is a 2.4 meter dish, exclusively used for AMSAT. And we have a shelter there, a kind of container. In this container we have some 90-inch racks, which we can fill with some equipment for monitoring our downlink, for uplinking some telemetry signals, some pseudo beacons, and the LiLA system. I will come to that later on. So the transponder on the spacecraft is a simple bent pipe transponder. There is no computer in this module, so no telemetry beacon, nothing. So it's just a bent pipe linear transponder. Actually, we have two of them. And we plan to provide some beacons for the user to adjust power levels from the ground. So indeed, the spacecraft itself has an onboard computer. We will even get some telemetry. And this will be filtered out. Maybe in our old style 400 bit per second AMSAT format, we will uplink it from Doha so that users can see some telemetry, output power, temperature, things like AGC, things like that. So what you see here are both spacecraft from SLSat. So this is SLSat-1, which is shared, half of the satellite is shared with Eutelsat. And this is the SLSat-2 spacecraft, a real sketch from the manufacturer. This is basically a poster you can find on the internet from SLSat. And SLSat-2 is expected to be launched at the end of 2016 at 26 degrees east. And as I said, it will carry hosted amateur radio payload, S-band uplink, X-band downlink, linear we have two transponders, they will be linear, so actually all modes are possible, and the planned lifetime is at least 15 years. It's interesting to note we have some traveling wave tube amplifiers, so they might have, I think, 30 or 40 on the spacecraft in total for all their transponders. And they can rearrange these TWTs. So we have the spare TWTs. So the worst thing could happen is that they have a lot of fails on their TWTs, and it can happen, okay, they will say, please give us your TWT, and then we are off. But this is the worst case. I think it may not happen. Okay, so yeah, we will be in a geosynchronous position, 25 degrees east. That means the spacecraft will be constantly over the same place over the Earth at a distance of roughly 36,000 kilometers. And basically you don't need movable antennas. You can have a fixed antenna like a satellite dish pointing to the spacecraft. This shows you the Earth coverage seen from the spacecraft. So we have partly so this is part of South America. Brazil is in the footprint. Unfortunately, North America is not. But you know, you will hear later more about that. There is something else coming up. And yeah, Africa, Europe, indeed, is fully covered. So I think even so that we cannot cover the whole Earth, like with our Phase 3 spacecraft, I think we will have a nice coverage and yeah, a lot of possibilities for communication. This is another perspective, so where you can clearly see what is in it, what is not, and so basically even here to the Philippines, we will be able to have some long distance contacts. Sticks. So we have, as I said, we have two transponders, a narrowband transponder, which is about 250 kilohertz wide. The preferred modes here are SSB, CW, Morse communication, but also other modes, other narrowband modes are suggested on this kind of transponder. So even digital, whatever, if it is narrowband is fine. S-band uplink, X-band downlink. Something is screwed up here, sorry. As usual, I prepared this last night. Yeah, so we have the narrowband transponder, and in parallel we have a wideband transponder. Both transponders can operate in parallel, and each transponder has a dedicated double TWT with roughly 100 watt output on X-band. So part of the early discussions we had with SISAT and QRS was, okay, we have the first P4A spacecraft, but we have the capacity. They were always thinking, SISAT was also like, why are you talking only about it small, 250 kilohertz? Why not a real wideband? And so on. So okay, we said, why not having a wideband transponder for high-speed digital kind of transmissions for DATV? So that's why we basically, and that was really a suggestion by SI, that they suggested, okay, why not also add a wideband? So the second linear transponder will be 8 megahertz wide. Yeah, it will basically provide capability to have the first DATV transponder in space. So we can even have several channels in standard resolution. I think now with the latest technology, higher compression, it's even possible to have several high definition channels. And I have seen in Friedrichshafen, it was quite nice. There was this French guy. I'm not so much in this kind of business, but it was quite nice to see. I think he was able to do DATV in 300 kilohertz bandwidth. Yeah, so quite interesting. So it could be, we can also have a lot of lower resolution channels. So this will be quite fascinating. But on the other hand, I think also with the British Amateur Television Society, with the German ones and so on, we need to think about how to organize this kind of transponder, because for the commercials it's easy. They have coordinated stations, but with our kind of uncoordinated operating style, how to get all this together is not quite sure. What we will do is we will provide some uplink stations from Qatar, actually from the, what I mentioned before, from the spacecraft control center. We plan to have the capability to uplink some images, some DATV signals, just for users to start with just receiving, to have some kind of content. And from there on, we have to really think about how can we organize multi-user activity with kind of DATV. Okay. Sorry?
Frequency, just for reference, so don't write it wrong. Write it down wrong. Downlink for the wideband is 10.4.
Can you use the microphone?
Yeah, Achim, that's correct. Yeah.
10.495.
10, here's a typo, 10.495. I should have corrected this, but I forgot this again. Second time. So anyway, we will publish the exact information on the website, on our magazines, reprints in AMSAT-UK. So there might be small changes, but basically frequencies are fixed by now, so we do not expect too much changes. Yeah. Having a spacecraft for the first time in this kind of orbit, it is very hard to determine how many users will be there. So, yeah, we made some estimations, but for example, if you're saying the visible population, seen by the spacecraft, 5.2 billion people. If you say, okay, 0.05% of them are amateurs, we still have, because of China, we still have 1.7 billion possible amateur radio operators. So honestly, we don't know what will happen. It's very hard to predict because it will be very easy to use. We already see manufacturers, amateurs are preparing, building equipment. We will see more in a few minutes. So it's hard to say. We made some estimation based on experience with Oscar 10, Oscar 13, Oscar 40, and we thought, okay, for narrowband operations, a 250 kilohertz transponder should probably do. It will allow roughly 90 simultaneous SSB contacts in 24 hours every day, every week, every month. So we hope this number will more or less fit. We just have to see. On the other hand, if it's overcrowded like on shortwave in the past, it could also attract a lot of people. And we think it's better having the users concentrated rather than having them spread over several megahertz where they don't find each other. We had this problem, I believe it was Oscar 10. The L-band transponder was very wide. Yeah, and we saw people calling, but they did not find them because this transponder, I think, was 700 megahertz wide or something. So it was, yeah, we just have to see how it will work. It could be that it will be very crowded in the beginning and later on changes, but okay, let's see what will happen. Yeah, as I said, the SISAT Satellite Control Center is located near Doha. From there, it is planned to do the in-orbit verification. So after launch, there will be extensive tests to verify if all the parameters are within the specification, within the requirements, because this could also be reliability issues from SISAT, because Melco has to build it and it has to be functional as planned, and if not, it might be that, say, SISAT will ask some money back or whatever. What we also plan is, we plan to have this Lila system. So you remember Lila from Oscar 40. By the way, our Arabic friends, they really like the name Lila. So this is a very nice name for them. So we keep the name Lila for this. It is a ground-based Lila system. So on Oscar 40, we had the Lila in the spacecraft. You remember Lila was, if there are users with too much uplink power, crocodiles, we called them in the past. So we are going to make a marker tone. So whenever someone is using too much power, there will be marker tone on this frequency, or some kind of nasty signal, so that you know, okay, I have to reduce my power. And this Lila system, we call it Lila 2, will be ground-based. So it will be in the control center in Doha, analyzing the passband, kind of software-defined radio, analyze, so can even handle the multiple stations and generate these marker signals. The Lila will also generate some pseudo beacons, as I explained, so we will have access to the telemetry stream from the whole satellite. It will be filtered, so all telemetry data which is relevant for us will be uplinked to the spacecraft, to the transponder, so that you can, say, use a simple decoder and see, okay, temperature, current, AGC levels and things like that. And so, as I said, the ATV transmissions are planned, maybe using webcam, whatever, from there. And there will also be ham radio chic. So I guess when there's a great opening day for the whole spacecraft, His Excellence will come there, and we'll also have a chance to go into the ham radio chic and hopefully make the opening QSO for our spacecraft, because one of those members of the family is a radio amateur, and he is the also the president of QRIs. Yeah, as I said, we will have a dedicated 2.4 meter dish. And hardware we are currently constructing. We hope also for some help from AMSAT-UK, especially regarding Lila. And so this rack is currently, we are designing, we are at the moment doing the specification, and this rack will be partially built in Germany, and we will set it up together and then bring over to Qatar. Yeah, before running out of time, I did this actually for our Qatari friends to look what kind of equipment is already available on the market, and they indeed asked what is also the price. Is this something amateur radio operators can afford? Because one of the very important missions why Qatar wants to do this is they want to use this for educational purposes. They want to get school kids involved. They want to make projects with schools, say schools in Qatar, making contacts with schools in other countries for educational purposes. They want to develop technology. They want to train the engineers to understand how does it work, what can be done, build small equipment, mobile ham radio operation. So Qatar is really promoting amateur radio in the country, and I think this is good, so why not? So the following slides are basically just to show up, okay, there's already some equipment available, others is to come, so, but basically it will be very simple. You can use small antennas. I have a slide which I want to show first. So this is one of the official presentations from SHILSAT. It was also presented, I think, by Graham at the IAU conference recently, or ITU, Graham, I don't see him. Also giving their requirements. So transponder will see the whole Earth. I wanted to show the footprint. Let me see, frequency band selection. So we had discussed various possibilities, but because of available hardware on the spacecraft itself, it turned out to be an SX combination. Because with this combination, it was easier for SHILSAT, and especially in the manufacturer, to provide already off-the-shelf hardware. And especially with the X-band downlink, our benefit is that we can share the same KU band payload using off-the-shelf TWTs also for our amateur radio transponder. Yeah, I think this is a slide I wanted to show, especially regarding frequencies uplink, downlink. So the narrowband transponder S-band uplink is right-hand circular polarized, while the downlink on X-band is linear vertical for the narrowband. So this is LVP. That means linear vertical polarization. And for the wideband, we share the same uplink antenna. So it's right-hand circular up on the uplink on S-band, and the downlink on X-band is linear horizontal polarized. Yeah, this actually is a payload diagram. And what you can see here, we even have redundancy. So we have two S-band receivers. So actually this is the uplink. We have some filtering over here. And then we have a splitter, and we have S-band receiver for the narrowband, S-band receiver for the wideband. And each of the S-band receivers even is double redundant. So there is even a redundant receiver for each channel. And basically we have the same for the transmit path. So here's some switching for the TWTs. And at the end we have bandpass filters, and actually here we have the combiner for the antennas, so horizontal and vertical 1 feet for using the available antennas. So they try to make it as much as compatible with the rest of the spacecraft, which is good. So the target user segment, So these are very, the calculations basically are more or less a worst case. So say for a station in Brazil, in a rainy area, in a 90 centimeter dish will be good enough. 60 centimeter dish around peak coverage, basically Europe, Africa, so in the middle of the footprint, and basically everywhere 75 centimeter dish is good enough. And for the uplink, 10 watt, we planned for 10 watt BU books amplifiers, which are very cheap, for uplink. Okay, we can go back to the other one. So there are a lot of possibilities. I'm pretty sure within the next few months until launch, a lot of people will think about. We had the ham radio fair recently in Friedrichshafen, and I already talked to many people which are now designing combined feeds so that you can use a single dish for uplink, downlink. People are working on converters. So we, for example, we have company Kuhne. These are indeed really high quality, commercially made transponders, amplifiers. They come with a price which is still not so bad, let's say. For example, here if you for DATV, you need probably a little bit more power, but such equipment is available. And it's even so that if you look on eBay, if you search on eBay for these kind of Spectria linear amplifier board, this has an output of 75 watt, needs about roughly 1 watt of input power, is available for $99. I guess after presentation in Friedrichshafen and before, prices will go up because demand is getting high. It was quite funny on the QRS. Also, nobody from QRS was representing it in Friedrichshafen. They had a small booth, a small poster, and a ham radio friend from Austria already had some leaflets for down converters already modified for AMSAT-2 frequencies. Not so expensive. What was it? I think 50 euro or something. 30 euro he offered. So people already started trying to do something. Okay, dish, as I said, even a 60 centimeter dish will do, depending on what is your expected signal to noise ratio. Downlink converter, for example, are available. Here is a one with a waveguide connector from Kuhne, 240 euro, but as I said, preamplifier. It can be even done cheaper. There is even some DATV equipment already available. So if someone wants to even uplink DATV signals, okay, I think somewhere in the order of 600, 700 euro. This is commercial grade quality, but it's possible. It's available already. It can be done. For the downlink, for the DATV downlink, it's very cheap, and that is the reason why we think about providing some. In the first time we will uplink permanent signals, like on a TV transponder, so that users can tune in and start at least looking at it. So you can just use a normal, simple DVB-S receiver from the supermarket, very cheap for normal TV. Don't need to modify. What you only need is an LNB, and as I mentioned, there are some Chinese LNBs available for 20 euro, which can be easily modified. They are already on internet on this address. Somebody explained how to modify such an LNB. So basically, if you already have an old satellite receiver, a 20 euro LNB, and then you will be able to receive the ATV signals from AMSAT-2. And just to show as a demonstration, Michael Fletcher from AMSAT-DL, he created ultra cheap receive equipment. So he used, I think this is a 90 centimeter dish, but Finland is very far out of the coverage of SHILSAT-1. So what he did, he tried to receive the SHILSAT-1 telemetry beacon using one of those ultra cheap octagon PLL LNBs for €12, 150 centimeter offset dish. And he used a FunCube dongle, some software, and he was able to receive this telemetry beacon, very stable in frequency with very good signal. So in theory, with the coverage we will get with SHILSAT-2, say with €20 for LNB, €150 for FunCube dongle, you are able to receive the narrowband transponder and listen to the traffic. This, as I said, is commercial equipment. And now I would like to turn over to Achim. Achim has some samples to show to you. Also Mikio-san from Jamsat brought some hardware with him. So also our Japanese friends are not in the footprint of SHILSAT-2. They are really hot in this, I must say. And they are already building hardware. They want to support us here in the footprint of SHILSAT with some very cheap, nice ground station equipment to be used on SHILSAT-2. And it's not a secret, if we all behave well with SHILSAT-2, with how we use the spacecraft, if we don't abuse it, if we behave well, if we can make nice projects out of it, especially regarding school activities in Qatar, if we really can demonstrate the good things of amateur radio to the government, then I was told there is a good chance we will fly SHILSAT-3. It will probably be 1-to-1 copy, and SHILSAT-3 is probably going to be located much further east, with the possibility, not with the possibility, then Japan will be visible too on this spacecraft. So this is our hope, that together with QRS we can promote amateur radio to the government of Qatar, demonstrate the good side of amateur radio, and with some luck they will be, we might even see another spacecraft from Qatar. Yeah, so this is actual situation. So watch the space until next year, and yeah, I think this will be very exciting, and especially after the lack we had after phase 3D, after Oscar 40. Phase 3 is still not in orbit. We have hoped to get it in orbit already, but you know, things are not so easy anymore. So we see this opportunity really as a good compensation for the loss of Oscar 40, and we hope that this will really promote amateur satellite activity. And I think it will be a big boost. I think when this spacecraft is up, Qatar will really write some new pages in our amateur satellite history, and I think I really hope for this. I really look forward, and that's the reason why AMSAT-DL is really strongly supporting, giving support to Qatar and helping to get the things together. Okay, so I will hand over now to Achim. Achim already also built some hardware, and so he will show you how easily it can be to operate SHILSAT-2. Thank you.
Okay. First of all, I need to make a small disclaimer. I'm no expert whatsoever on actually designing and building gigahertz circuits, but what you see here is just how I would call it a lecture to myself, whether it's actually feasible to do it and whether I might or might not be successful in actually doing it. What you see here is a prototype of a 3 centimeter down converter, and if you have seen the 3 centimeter down converters you can buy commercially, most of them are built on Teflon substrate, Teflon ceramic substrates whatsoever, because of the losses of the FR4 material. And the rationale is quite sound behind this, because FR4 is terribly lossy on 3 centimeters. But then again, you say, well, it's not so easy to make a, let's say, prototype on FR4, on Teflon, because if you go to one of these PCB pool manufacturers and you tell them, oh no, I don't want your FR4, I want this special Rogers 4000 whatever, then tell you, okay, but then we cannot put you in the pool anymore. You have to basically pay for the whole sheet, and then it will cost you a fortune. And so I said, okay, the only way of reducing the FR4 losses is actually reducing the FR4, which means that you basically, is this a pointer? It is. Reduce the length where the 3 centimeters is actually on the FR4. And what you see here is just this small trace here. That's all you have, that's all which is 3 centimeters on the whole board basically, except for maybe another trace here. So this is kind of a, let's say, evolved design from something I did a couple of years ago with a friend of mine for the Deep Space Network receiver, for homebrew Deep Space Network receiver, which we also did on FR4. And what you actually see here is not very complicated actually. You have here VCO, which is from Hittite, and it actually is running on something like 9 point whatever gigahertz. You have a PLL chip here, you have a PIC processor, and this is basically just a standard synthesizer. And I would say, what, 10, 15 years ago, building such a synthesizer would be quite some expert's work, because, I mean, soldering all these together is not the problem, but there's a tricky bit here, which is a loop filter. And you have to make sure that this loop filter actually works properly and is, let's say, matched to the tuning sensitivity of the VCO and the properties of the PLL. And I had the fun of visiting once a lecture how to, let's say, manually design such a loop filter. Believe me, you don't want to do this. Fortunately enough, the manufacturers of these PLLs, in that case analog devices, they provide simulation software where you can basically enter all the properties and then press synthesize, and this will give you just the schematics of the loop filter, which in the easiest way of all might be just a simple RC, maybe a 2-stage RC or something like that. So it's quite nice, and you simulate it, you build it, and miraculously it works. Which, I mean, I've been used to other simulation software where you simulate it, you build it, and you throw it into the trash bin. So that works quite nicely. And the PIC processor, in that case, if you don't have to jump around with the PLL with the synthesizer and all your frequencies, it only has to program the PLL once. So the amount of code you have to write is literally maybe half of page code, which is all fixed, let's say, numbers you can get out of the data sheet. You have here, well, I call it reference input. There's another SMA connector. If you go back one slide, you see that quartz crystal. And that's just there for, let's say, for ease of testing, because they don't have always the 10 megahertz from some rubidium or oven or whatever available. So I can basically use the 10 megahertz internal one, or I just take this out, put a bridge in there, and then I can phase lock it to some external reference. Power regulators, not very hard. The VCO, again, you get from Hittite. This one is a mixer. I think it's also from Hittite. You can imagine the really hard part is soldering this, because it's all very tiny, and to make things even worse, these chips have an exposed pad underneath. So soldering these is a bit tricky. There are a couple of tricks how to do this, even with a hand soldering iron, or you do it in the oven, let's say at home. There has been a very good example of, I think it was the prototype boards from Howard for the FunCube dongle. There's somewhere in the web a picture where he literally baked them in the oven at home. So it can be done.
Also frying pans, you have to use non-stick.
Non-stick frying pans, excellent. Excellent hint. And then again, I mean, the LNA, again, from Hittite, they're kind of 50 ohms matched, and I would never claim that this is a kind of a cutting-edge design. It somehow works. I have received a beacon, a 10 gigahertz beacon in Switzerland with it. It works. The beacon sounds fine, so it's not like whiny or something like that. So I'm pretty sure that this works. Again, this was for personal education to see how hard actually it is. Yeah, I don't call you now that you can all build this yourself, or you should all build this yourself, because I mean, Michael Fletcher has shown that this with his PLL LNBs, I mean, it can be rather easily be done to make your own 3 centimeter downlink setup. On the other side, of course, I have gone to something which is a little bit more in the, let's say, frequency reach of what I've done before. So what I did is an up converter, which is, you might see it's the same design, partially because I was too lazy to make another mechanical design for the box. Second, all this lower part is basically the same. What is exchanged is the VCO. This one is now for mini circuits. The mixer is from mini circuits. The filter, I think, is a Neosit filter. And the real, let's say, I would call it maybe game changer part is a final amplifier here from Analog Devices, which has something like 250 milliwatts. And it's really, really cheap. And this is really enough to drive the next stage, which will take you up to 5 to 10 watts. However, I don't have a picture of this, but since we have been in contact with the Japanese colleagues from AMSAT, I've been especially in contact with Akira Kaneko, GA1OGZ. And he has improved this design. We have been in contact about this design, and he has improved this. Something like that. So hats off to Akira-san, if you see me. Thank you very much. This is looking very, very beautiful. It has the same final stage. He has compacted it a lot. The filter has been improved. I think the output power is even a bit increased. We are exceeding now 320 milliwatts. Hence the big heatsink on the backside. But this is very nice. And I think along these lines, something like this can be made available to the amateur radio community to easily get access to SHALSAT-2. For the downlink, I can remember the complaints when Oscar 40 was being designed about, oh, Mode S, this is so complicated. We want our 2 meters, 70 centimeters combination. I'm not going to ask who is doing 10 gigahertz terrestrial amateur radio, but whoever of you has set up a 10 gigahertz or X-band direct-to-home satellite dish on their home roof. So I would say maybe half of the audience already. And that is probably the same amount of work you have to do for SHALSAT-2. And it will get less embarrassing, because this time it looks like a proper antenna because it's looking up in the sky, right? In Germany, we have used exactly the same dishes for a couple of times for interlinks, and they were pointing down. And it happened more than once. Then some mechanic was ringing at the door. I mean, oh, your antenna is wrongly tilted. It's pointing down because of the last thunderstorm. Can I fix it for you? So I said, no, everything's fine. So, setting up 10 gigahertz for SHALSAT will be no more difficult than setting up your dish for Eutelsat, for Astra, for Hotbird, whatsoever. The only thing you need is an LLB, PLL LNB, modified one, or if it's unmodified, then a small intermediate down converter to put it somewhere to let's say 70 centimeters, 2 meters, or a FunCube dongle, because this is perfectly able of receiving at, I think it's 618. Yeah. No, 618 would be the narrow band, 368, so somewhere in the 700-ish megahertz range. But FunCube dongle will be perfectly able of doing this. So hold your breath. I'm pretty sure within 12 months, when we meet next time, we'll have much more information, much more hardware, both from our colleagues at AMSAT, from other persons like probably Michael Kuhne, DB6NT. We have contacted him. He's in the start gate, so to speak. And yeah, we are all terribly looking forward to move ahead, and exciting times. Exciting and busy times. Thank you.
For BATC. Just before we go for lunch, could I just do a quick plug with a BATC hat on? Peter was talking about TV transmitters. This is a BATC DTX1, works on 13 SEMS, produces with different data rates of DATV. About £400, I think now, BATC are selling them for. So the transmit side is already catered for, different data rates, different bandwidths. Also, you may not have noticed, but up on the ceiling there is like a CubeSat. It's a bit bigger than a CubeSat because somebody's built a Raspberry Pi low reduced bandwidth TV transmitter into it, but they've built the transmitter into an Edison box, which makes it a bit big for a CubeSat. But that's transmitting 300 kilobit video actually across the room on 70 SEMS. The receiver, if you want to have a look, is in the back. So there's a lot going on within ATV in advance of what the satellite launch date. So thank you very much indeed. It's great.
Yeah.
Thank you.
Thank you. Questions? The question was, what is the required uplink power? Being on 13 centimeters, as you would know from, let's say, the downlink experience from Oscar 40, this depends a bit on how well your, let's say, takeoff is, right? If you have a bit of trees, you need a bit more. Yeah. The optimum would be somewhere in the range of 5 to 10 watts into, well, depending on where you are in the on the Earth disk, so to speak, between 60 and 90 centimeters. Then again, especially on the downlink, again, X-band, you know this again from TV signals. When the thunderstorm is coming, signals will drop significantly on X-band because of the water attenuation. So you want to have a little bit of a reserve there. We think 60 centimeters would be just fine, but if you want to be a bit on the safe side, I would recommend 90 centimeters. We had already proposals from several persons about a combined feed for a 90 centimeter dish. Mechanically and antenna wise, it looks very promising. It needs some further optimization. One has to bear in mind that you will have something like a 10 watt transmitter next to a super low noise LNA on 10 gigahertz. Whether or not this needs some additional isolation remains to be seen. But, well, we have something like, what, 15 months left? Whoever is willing to take on this challenge shall be invited. I'm not saying, well, challenge is a bit harsh. I mean, wants to answer this question shall be invited. It's certainly doable. I'm pretty confident there, but remains some work to be done.
Question from the internet, or actually a couple of questions from the internet that came in. There's actually a lot of suggestions of people that are saying, like, can we maybe batch up some of those 10 gigahertz LMBs and manufacture a whole batch of them? So can we just sign up and see if we can do that? That's the first one. And the second question is actually from Edson in Brazil. He's asking, are we able to work the transponder from 6 degrees elevation? So he was actually checking if it would be okay for him to work the transponder.
Question number one, batch job. I actually don't know. Looking at the price of a PLLLB in, let's say, the free market, which is currently something around 10 euros, pounds, dollars, whatever, I have kind of a hard time of believing that we might be able to talk one of these manufacturing companies into a batch job for 500 PLLMBs, because for them 500 is a very, very low number. And it might be more effective to get somewhere hold on a batch of special temperature controlled crystal oscillators. And there have been a lot of tutorials in the internet how to change this TCXO to move the intermediate frequency to somewhere where we can easily access it. So that might be the way to go, but I mean, this may change. Question number two, elevation, 5 degrees, 6 degrees. So that is actually, as Peter has shown here, that's the coverage from 26 degrees east, which is the proposed orbital location. You see the 5 degrees and 10 degrees, I think still hear me? 5 degrees and 10 degrees elevation circles. I think our analyses were always done for 10 degrees edge of coverage. 5 degrees might need a bit of extra antenna gain, both for uplink and downlink. I'm pretty confident if you don't have any trees or buildings inside, it should be okay. I'm also pretty confident once you have not direct line of sight, it's basically game over, especially on 10 gigahertz. So there's little margin for error. But I'm pretty sure it should work. But we also had some elements in our discussion, if I remember, that especially in Brazil, you have to take into account the additional attenuation because of the longer path lengths in the atmosphere, just because of the water vapor on 10 gigahertz. So you might increase even beyond maybe 120 centimeters.
Thank you. That's all from the internet.
No more question? Okay, no more questions. Then, but yeah, again, feel free to contact Mikio.
Hi, this is Mikio Mori, DH2VA from Japan. And from AMSAT, Japan is out of sight. From AMSAT, Japan is out of sight, but not out of mind. If you see the edge of sight, the eastbound is East Asia, and friends of ours in Thailand, for example, are very much interested in satellite, and they want to install some ground station for SHRSAT in Thailand. So hopefully other countries, we hope to activate, because how Peterson asked how many users. Also, we wonder how many countries QRV, there are QRVs like AO13 or AO10. So another one is Antarctica. There's South Edge. If you check the atlas, there's some observatory of Japan in south of South Africa. So we want to talk about such possibility with officials. We had to, of course, we had to make a lot of discussions with government, but that is a very interesting. From snowstorm in Antarctica and very hot in Qatar, or many other schools in other countries for like school contact or something like that. This SHRSAT can provide such educational opportunities. So that is one of our dream, how to use this satellite. So I hope many of us met QSO with AO10 or AS13s. So I hope to work and meet many people via satellite again soon. Thank you very much.
Yeah, thank you very much, Mikio-san. Yeah, as Mikio said, I hope there will be some very interesting possibilities for demonstration what amateur radio can do. And I forgot to say about the DATV transponder. Our idea is not, we discussed this, what can we do, for example, when we have this permanent uplink station in Doha, shall we connect it to internet? Shall we allow uplinks through internet? And we decided no. We should use our ham radio resources to demonstrate directly. And my hope is, in 2 years, when we have the AMSAT Colloquium here, that we can do the DATV live transmission live through SHRSAT2 from here. That is my hope, my dream. Okay, thank you very much.
Thank you, Peter. Thank you, Achim. Well, as the conference program organizer, that's 2 signed up for in 2 years' time. Thank you. It's going to get exciting times for you guys, and
Very exciting.
congratulations on the contract to start with and how it's panned out. Thank you very much indeed. From the logistical point of view, it's now lunchtime.